You wake up exhausted even after 8 hours of sleep. Your jaw is clenched, your shoulders are tight, and you haven't even checked your phone yet. You reach for coffee to feel normal, but normal never quite arrives. And now you realize this is just how you feel every single day. Your body aches in places that have no injury. Your stomach churns before meetings that shouldn't matter. You snap at people you love over things that don't deserve anger. And now you're wondering when you became this person. If stress is just temporary, why does it feel permanent? If your body is designed to heal, why does it feel like it's breaking down? Something uncomfortable that passes when the deadline ends or the crisis resolves. But what if stress isn't just happening to you? What if it's changing you? And what if, right now, your brain is being physically restructured by stress you don't even realize you're carrying? If you could see inside your skull, would you recognize what's happening? What if the person you're becoming isn't a choice, but a consequence of neural pathways being carved deeper every single day? Neuroscientist Bruce McEwen at Rockefeller University spent over 40 years studying what chronic stress does to the brain. What he discovered is unsettling. Stress doesn't just make you feel bad, it literally reshapes your brain's architecture, shrinking some regions, enlarging others, rewiring the connections between them. And here's what most people never learn. You're not just experiencing stress, you're being remodeled by it. The truth is, your brain is not a fixed structure. It's plastic, constantly changing based on what you experience most often. And if what you experience most often is stress, the racing thoughts, the tight chest, the feeling that something's always wrong, your brain is adapting to that reality. It's not failing you, it's optimizing for survival in an environment it perceives as threatening. And once you understand how this rewiring happens, you can begin the process of reversing it. This isn't taught in schools. Most people live their entire lives not knowing their brain is being reshaped by invisible forces they could learn to redirect. But the neuroscientists who study this, they've mapped the exact mechanisms, and they've found that the brain's plasticity works both ways. But here's what you need to know, and what changes everything once you understand it. Your brain can be rewired by stress, but it can also be rewired by the practices that reverse it. And today, that's exactly what we're going to fix. So here's how we'll do it. Step by step, starting with the simple shift that changes everything. First, we'll break down 4 specific ways chronic stress physically restructures your brain. Changes that even doctors miss when they tell you to just relax. Then we'll explore the surprising neuroscience behind why your brain prioritizes stress responses over everything else, and why this happens even to people who seem to have their lives together. But most importantly, we're going to give you 8 powerful strategies backed by neuroscience research that you can start using today to begin reversing the damage and rebuilding the brain you want. These aren't vague wellness tips or meditation retreats. They're specific, evidence-based interventions that physically change your brain structure, even if you can only dedicate 10 minutes a day. By the end of this video, you'll understand exactly what chronic stress is doing to your brain right now. You'll know why your brain prioritizes survival over well-being and what that means for your daily experience. And you'll have concrete tools that work in real life, backed by brain imaging studies, without needing perfect conditions, endless free time, or a complete life overhaul. Your brain operates like a garden that grows whatever you plant most often. If you're constantly planting stress, through your thoughts, your environment, your reactions, your brain grows more neural pathways devoted to threat detection, worry, and survival mode. The peaceful, creative, connected parts of your brain, they start to wither from lack of use. We've all felt this. That sense of being perpetually on edge, unable to fully relax even when nothing's wrong. But how do we know this isn't just psychological, something we can think our way out of? For over 50 years, neuroscientists have been using brain imaging technology to watch what happens to the brain under chronic stress. And what they've found is both alarming and hopeful. In the 1960s, neuroscientist Bruce McEwen at Rockefeller University began studying what he called allostatic load, the cumulative wear and tear on the body and brain from chronic stress. Using brain imaging and animal models, he discovered that stress hormones like cortisol don't just create temporary discomfort. They actually change the physical structure of the brain, particularly in three key regions: the hippocampus, the amygdala, and the prefrontal cortex. It wasn't theory, it was visible on brain scans, measurable, reproducible. People under chronic stress had physically smaller hippocampi, the region responsible for memory and learning. Around the same time, neuroscientist Robert Sapolsky at Stanford University spent decades studying stress in primates and humans. His research revealed something critical. It's not acute stress that damages the brain. It's chronic, unrelenting stress without adequate recovery. Your brain can handle a crisis. It's designed for that. What it can't handle is living in a state of low-grade emergency for months or years at a time. That's when the rewiring begins. That's when temporary survival adaptations become permanent structural changes. In the 1990s, psychiatrist J. Douglas Bremner at Emory University used MRI technology to study trauma survivors and people with chronic stress disorders. He found that the hippocampus, your brain's memory center, literally shrinks under prolonged stress exposure. Not temporarily, structurally, measurably smaller, with fewer neural connections. At the same time, the amygdala, your brain's threat detector, grows larger and more reactive. Your brain is physically reorganizing itself to prioritize survival over everything else. Together, these insights reveal something most people never realize. Chronic stress isn't just something you're going through. It's something that's changing who you are at the neurological level, reshaping the organ responsible for every thought, feeling, and decision you make. Your hippocampus shrinks, your amygdala enlarges, your prefrontal cortex, the part of your brain responsible for rational decision-making, weakens. This is what chronic stress is doing to you right now, beneath your awareness. You can see this in your daily life, even if you can't see it on a brain scan. You walk into a room and forget why you're there. You read the same paragraph 3 times without absorbing it. You can't remember what someone just said to you. Your memory isn't failing because you're aging or not trying hard enough. Your hippocampus is literally smaller than it should be, struggling to form and retrieve memories while under siege from stress hormones. This is your hippocampus under stress, and you've felt this your entire life without understanding what was happening. The hippocampus doesn't just store memories, it regulates your stress response, helps you learn, and contextualizes your experiences. When it shrinks, you lose more than memory. You lose the ability to accurately assess threats. Everything starts to feel dangerous. Your brain loses its capacity to distinguish between real threats and false alarms. Research by neuroscientist Yvette Shaline at Washington University showed that people with chronic stress have hippocampal volumes up to 14% smaller than non-stressed individuals. That's not a subtle change. That's significant structural atrophy visible on brain scans. And here's the trap. A smaller hippocampus makes you more vulnerable to stress, which shrinks the hippocampus further. It's a feedback loop where stress begets more stress, and your brain adapts by becoming a more efficient stress machine. Then there's what happens to your amygdala, your brain's alarm system. Neuroscientist Elizabeth Phelps at New York University found that under chronic stress, the amygdala doesn't just become more active. It grows larger and develops more connections. This might sound good, more brain tissue, more connections, but it's not. A hypertrophied amygdala means you're constantly scanning for threats that don't exist. A neutral facial expression looks like judgment. A delayed text feels like rejection. A minor setback feels like catastrophe. You're not overreacting. Your amygdala has been structurally modified to overreact. It's doing exactly what chronic stress trained it to do. But the most devastating change happens in your prefrontal cortex, the part of your brain responsible for executive function, rational thought, and emotional regulation. Neuroscientist Amy Arnsten at Yale found that even mild, uncontrollable stress impairs prefrontal cortex function within minutes. And chronic stress? It causes the prefrontal cortex to literally lose synaptic connections. The dendrites, the branching structures that allow neurons to communicate, begin to retract, like a tree losing its branches. You lose your ability to focus, plan, make decisions, and regulate emotions. That's why stress makes you feel scattered, reactive, unable to think clearly. Your brain's executive control center is being dismantled while your threat detector is being amplified. You're becoming less capable of rational thought at exactly the moment you need it most. Research by neuroscientist Nuno Sousa at the University of Minho in Portugal showed that chronic stress actually reverses the normal pattern of brain connectivity. Normally, your prefrontal cortex controls your amygdala, keeping emotional reactions in check. Under chronic stress, this relationship flips. The amygdala starts driving behavior while the prefrontal cortex becomes a passenger. You stop responding to life thoughtfully. You start reacting automatically from a place of fear and survival. And perhaps, most insidiously, chronic stress affects your brain's neuroplasticity itself. Neuroplasticity is your brain's ability to form new connections, learn new patterns, and adapt to new information. Neuroscientist Carla Nasker at Rockefeller University discovered that chronic stress reduces levels of a molecule called acetyl L-carnitine, which is essential for maintaining neuroplasticity. Without adequate neuroplasticity, your brain loses its ability to change, to learn, to adapt. You become stuck in stress patterns because your brain has lost the flexibility to create new pathways. The very mechanism that would allow you to escape stress has been compromised by stress itself. Your memory center shrinks, your threat detector enlarges, your rational brain loses control, your neuroplasticity declines. This is what you've been up against beneath every moment of feeling overwhelmed, scattered, or unable to cope. But why does the brain do this to itself? Because every single one of these changes is an adaptation designed to help you survive what your brain perceives as a threatening environment. Your hippocampus shrinks because detailed memories aren't useful in a crisis. Your amygdala grows because detecting threats faster might save your life. Your prefrontal cortex weakens because deliberation takes time you don't have when you're in danger. In an acute emergency, a car swerving toward you, a predator attacking, these changes would help you survive. The problem? Your brain can't tell the difference between a car swerving toward you and an email from your boss. And here's the key: understanding this mechanism is the first step to reversing it. Why does chronic stress rewire your brain instead of just making you temporarily uncomfortable? Because your brain is the most adaptive organ in your body, constantly reshaping itself based on what it experiences most frequently. Neuroscientist Donald Hebb discovered this principle in the 1940s. Neurons that fire together, wire together. Whatever neural pathways you use most often become stronger, faster, more automatic. If you spend most of your time in stress mode, worrying, scanning for threats, reacting to problems, your brain builds more efficient stress pathways. It's not punishing you, it's optimizing for what it thinks you need most. Evolutionary psychologist Randolph Nesser at Arizona State University explains that your stress response evolved in an environment where threats were immediate, physical, and short-lived. A predator attacks. You run. The threat passes. Your body returns to baseline. Your stress system was designed for acute, episodic danger, not for the chronic, abstract threats of modern life. But your modern brain is experiencing stress constantly. Deadlines, bills, relationships, health concerns, news, social media, work demands, family obligations. None of these are life-threatening. But your brain processes them using the same ancient system designed for life or death situations. And when that system never shuts off, when there's no relief, your brain makes a logical adaptation. It assumes this is the new normal and restructures itself accordingly. Then there's the role of cortisol, your primary stress hormone. Neuroscientist Sonia Lupia at McGill University has shown that cortisol in moderate amounts is helpful. It mobilizes energy, enhances focus during challenges. But chronic elevation of cortisol has neurotoxic effects, particularly on the hippocampus. Cortisol receptors are densely concentrated in the hippocampus, which means this region is especially vulnerable to prolonged cortisol exposure. It's like watering a plant. The right amount helps it grow, too much drowns it. Your hippocampus is drowning in stress hormones, and the structural changes are the visible result. But there's also a neurochemical component that most people don't know about. Neuroscientist Christian Mirescu at Princeton University found that chronic stress suppresses neurogenesis, the birth of new neurons, particularly in the hippocampus. Your brain is supposed to generate new neurons throughout your life, especially in regions responsible for learning and memory. Chronic stress doesn't just damage existing neurons, it prevents new ones from forming. You're losing brain cells without replacing them, which explains why chronic stress makes you feel like you're cognitively declining. Then there's what happens at the cellular level with something called brain-derived neurotrophic factor, or BDNF. Neuroscientist Ronald Duman at Yale discovered that BDNF, a protein essential for neuron growth, survival, and plasticity, decreases dramatically under chronic stress. Without adequate BDNF, your neurons can't maintain their connections, can't grow new dendrites, can't adapt to new information. It's like removing the fertilizer from soil. Even if you plant new seeds, nothing grows. But there's also a profound social and cultural dimension to this biological process. Psychologist Robert Sapolsky's work shows that chronic stress is not evenly distributed across populations. People experiencing poverty, discrimination, unstable housing, or lack of social support experience significantly higher allostatic load. The brain changes we're talking about aren't just individual biology. They're the neurological signature of systemic inequality. When society creates environments of chronic uncertainty, instability, and threat, it creates brains that are structurally adapted to those conditions. This isn't about personal failure or lack of resilience. It's about brains responding exactly as evolution designed them to respond to genuinely difficult circumstances. Neuroscientist Lisa Feldman Barrett at Northeastern University adds another layer. Your brain is constantly running what she calls a body budget, managing resources like glucose, oxygen, and neurotransmitters. Chronic stress depletes your body budget faster than it can be replenished. Your brain starts operating in a state of perpetual deficit, which forces it to prioritize immediate survival over long-term well-being, automatic reactions over thoughtful responses, threat detection over opportunity exploration. Together, these mechanisms create a perfect storm, an evolutionary system designed for acute threats, neurochemistry that's toxic in chronic doses, cellular processes that shut down under prolonged stress, and social environments that keep people locked in stress states. No wonder your brain is rewiring. No wonder you feel like you're changing in ways you didn't choose. You're not weak, you're not failing, you're not broken. You're experiencing the predictable neurological adaptation to an environment your brain perceives as chronically threatening. But here's what changes everything. Neuroplasticity works both ways. The same brain that rewired itself for stress can rewire itself for resilience. Your brain adapted to stress because that's what brains do. They optimize for what they experience most often. But neurons that fire together don't just wire together. They can also wire apart. The pathways you stop using weaken. The pathways you start using strengthen. This is what you've been up against. A brain that learned to prioritize threat detection, that built superhighways to anxiety and dirt paths to peace. But the moment you understand this, something shifts. You stop seeing these changes as permanent damage and start seeing them as malleable adaptations. Your brain isn't broken, it's responsive. And if it responded to chronic stress by restructuring, it will respond to consistent new inputs by restructuring again. This takes practice. Your brain has been running stress patterns for years, maybe decades. But neuroscientist Richie Davidson at the University of Wisconsin has shown that measurable brain changes can occur in as little as 8 weeks of consistent practice. You can start today. Right now, actually. Here's how. Start with the most powerful intervention neuroscience has ever documented: aerobic exercise. Neuroscientist Karen Postal at Harvard Medical School reviewed decades of research and found something remarkable. Aerobic exercise doesn't just make you feel better temporarily. It directly stimulates neurogenesis in the hippocampus, increases BDNF levels, and promotes the growth of new neural connections. You're not just managing stress with exercise, you're physically rebuilding the brain regions that stress damaged. Research by neuroscientist Henriette van Praag at the National Institute on Aging showed that even moderate aerobic activity, 30 minutes of brisk walking 5 times a week, significantly increases hippocampal volume within just 3 months. The hippocampus that stress shrank, exercise grows it back. Here's what to do. Pick any aerobic activity that raises your heart rate to a moderate level. Walking, jogging, cycling, swimming, dancing. The key is consistency, not intensity. Your brain doesn't need you to run marathons. It needs regular, repeated signals that you're safe enough to grow new neurons. Try this. Commit to 20 minutes of walking 3 times this week, not as punishment, not as one more thing to stress about, as medicine for your brain. When you move your body, you're sending a message to your hippocampus. It's safe to grow, it's safe to learn, it's safe to be here. Once you've started moving, here's what to add. Mindfulness meditation targeted specifically at strengthening the prefrontal cortex. Neuroscientist Sarah Lazar at Massachusetts General Hospital used MRI scans to study people who meditated regularly. What she found was stunning. After just 8 weeks of daily meditation practice, participants showed measurable increases in grey matter density in the prefrontal cortex and hippocampus, and decreases in the amygdala. The exact opposite of what stress does to your brain. Meditation isn't about emptying your mind or achieving some mystical state. It's about training your prefrontal cortex to regulate attention and emotion. Every time you notice your mind wandering and bring it back, you're literally strengthening the neural pathways that stress weakened. Here's the practice. Sit for just 5 minutes. Set a timer. Close your eyes. Focus on your breath. When your mind wanders, it will constantly, gently bring your attention back to breathing. That moment of noticing and redirecting, that's the workout. That's your prefrontal cortex doing push-ups. Neuroscientist Richard Davidson at the University of Wisconsin found that even brief daily meditation sessions create lasting changes in brain structure and function. You don't need hours. You don't need perfect silence. You just need consistency. 5 minutes today, every day this week. That's how brains change. Now you can deepen this by addressing your sleep, which is when most brain repair and consolidation happens. Neuroscientist Matthew Walker at UC Berkeley has shown that sleep is not passive rest. It's when your brain clears metabolic waste, consolidates memories, and literally repairs damage from the day. When you're chronically stressed and sleep deprived, you're denying your brain the time it needs to undo the damage stress creates. Research shows that even one night of poor sleep increases amygdala reactivity by 60%. Chronic sleep deprivation accelerates all the brain changes we've been talking about. But here's the good news. Improving sleep quality begins reversing them. Here's what to do. Create what neuroscientists call sleep hygiene. Same bedtime every night. Dark, cool room. No screens for 1 hour before bed. Psychologist Alison Harvey at UC Berkeley found that cognitive behavioral therapy for insomnia, which focuses on sleep hygiene and thought patterns about sleep, is more effective than medication for long-term sleep improvement. Try this tonight. Turn off all screens at 9 p.m. if you sleep at 10 p.m. Read, stretch, or talk to someone instead. Your brain needs darkness to produce melatonin, and it needs routine to know when it's safe to repair. Here's a technique specifically for shrinking your overactive amygdala. Controlled breathing with extended exhales. Neuroscientist Andrew Huberman at Stanford explains that your breath directly controls your autonomic nervous system through the vagus nerve. When you extend your exhale longer than your inhale, you activate your parasympathetic nervous system, your body's natural calming mechanism. This isn't just relaxation, it's neurological intervention. You're directly signaling your amygdala to stand down. Research by psychiatrist Richard Brown at Columbia University showed that controlled breathing practices significantly reduce amygdala activation and improve emotional regulation within just 4 weeks. Here's the practice. Breathe in for 4 counts, hold for 4, out for 6, hold for 2. The extended exhale is key. That's what tells your nervous system there's no threat. We're safe. The amygdala can rest. Do this 3 times when you notice stress building. Do it before sleep. Do it in traffic, in meetings while waiting. You're not just managing stress, you're training your amygdala to be less reactive, one breath at a time. Another powerful practice is what neuroscientists call environmental enrichment. Deliberately exposing your brain to novel, complex stimuli. Neuroscientist Gerd Kemperman at the German Center for Neurodegenerative Diseases found that environments rich in novelty, challenge, and social interaction promote neurogenesis and synaptic growth. Your brain doesn't just need rest from stress, it needs positive stimulation to rebuild. Here's the practice. Learn something new that challenges you cognitively. A language, an instrument, a complex skill. The key is that it must be genuinely novel and require sustained attention. Research shows that learning new skills creates new neural pathways, increases BDNF, and literally expands the regions of your brain devoted to that skill. You're not distracting yourself from stress. You're giving your brain the raw material it needs to grow new connections. Try this. Commit to 15 minutes a day learning something you've always wanted to learn. Not for productivity, for neuroplasticity. Your brain needs reasons to grow, not just reasons to stop shrinking. Here's a technique for reducing chronic stress at its source: social connection with people who regulate you. Neuroscientist Stephen Porges at the University of North Carolina developed polyvagal theory, which explains how social interaction directly influences your nervous system. When you're with people who make you feel safe, your vagus nerve activates, your stress response calms, and your brain receives signals that it's safe to grow and repair. Research by psychologist Shelley Taylor at UCLA showed that social support doesn't just make stress more bearable, it literally buffers the brain from stress-related damage. People with strong social connections show less hippocampal atrophy and slower amygdala enlargement even under significant stress. Here's the practice. Identify 2 to 3 people whose presence naturally calms you, not people who try to fix you, People who help you feel grounded just by being there. Schedule time with them, not when it's convenient, regularly. Your nervous system needs co-regulation the way your body needs food. Try this. Reach out to one person this week and spend time together doing something low-key. Walk, talk, sit, be. Your amygdala literally calms down in the presence of safe connection. This isn't luxury, it's neuroscience. And for those moments when everything feels impossible, when stress is already spiking and you need immediate intervention, here's an emergency reset, the 5-4-3-2-1 grounding technique. Psychiatrist Dan Siegel at UCLA found that grounding techniques interrupt the amygdala's threat response by forcing attention into present moment sensory experience. When your amygdala is activated, it's focused on past or future threats. Grounding pulls you into the present, where most threats don't actually exist. Here's the practice. Name 5 things you can see, 4 things you can touch, 3 things you can hear, 2 things you can smell, 1 thing you can taste. This forces your prefrontal cortex back online, interrupts rumination, and gives your amygdala evidence that right now, in this moment, you're actually safe. Research shows this technique can reduce amygdala activation within 60 seconds. Keep this in your emergency toolkit. When the spiral starts, when stress feels overwhelming, your senses are always available to bring you back. These aren't all the interventions that exist. They're the 8 that neuroscience shows work most reliably, with the most evidence, requiring the least perfect conditions. Start with 1, just 1. Maybe exercise resonates, maybe breathing, maybe sleep. Pick the one that makes you think, I could actually do that this week. Because brain change doesn't require perfection. It requires consistent signals that things are different now, repeated often enough that your neurons start wiring together in new patterns. Start with one practice this week. Move your body once. Meditate for 5 minutes once. Improve your sleep once. Research by neuroscientist Michael Merzenich at UC San Francisco shows that neuroplasticity doesn't require massive interventions. It requires consistent ones. Your brain changes based on what you do repeatedly, not what you do perfectly. The goal isn't to eliminate stress. That's impossible and wouldn't serve you. The goal is to interrupt chronic stress long enough for your brain to begin rebuilding what was damaged. Awareness gives you that power. Consistent practice gives you results. Realizing your brain can be rewired by stress isn't discouraging. It's liberating. Because if stress can change your brain, so can you. Reversing brain changes takes time, and anyone who promises instant results is selling something. Your brain didn't change overnight, and it won't reverse overnight. But week by week, practice by practice, you start building new neural pathways that prioritize calm over chaos, connection over isolation, growth over survival. Here's what most people don't realize. You don't need to fix everything at once. You just need to give your brain consistent signals that it's safe enough to change. And those signals, you can create them. We can create them. We want to hear from you. Which of these 8 strategies are you going to try first? And have you noticed any of these brain changes in your own life? The memory issues, the constant alertness, the difficulty focusing? Drop it in the comments. Sometimes just naming what's happening helps you realize you're not broken. Your brain is just doing what brains do under chronic stress. If this video helped you understand what stress has been doing to you, share it with someone who's been carrying too much for too long. Send it to someone who needs to hear that their brain can change, that the damage isn't permanent, that there's a path back to themselves. Because when we understand what's happening beneath our skulls, we finally have the power to change it. Hit subscribe if you want more neuroscience that actually helps you understand your brain and gives you practical tools. We drop new videos every week. Try one practice today. Move for 20 minutes. Breathe for 5. Sleep 1 hour earlier tonight. Then ask yourself, If your brain can change based on what you experience most often, what do you want to experience more? If neurons that fire together wire together, which pathways deserve your energy? And if your brain spent years rewiring for stress, what might it become if you gave it years of something different? Maybe your brain isn't broken. Maybe it's just adapted to circumstances you can now begin to change. Maybe the person you're becoming isn't determined by the person stress made you. Maybe it's determined by what you practice, what you repeat, what you consistently show your brain is possible. That plasticity, that's hope, that's agency, that's proof that you're not locked into who stress made you. And that truth has been here all along, hidden in the simple fact that the brain that changed once can change again. This time, in the direction you choose.